Greetings. My name is Joel Chan. I'm the first author on this paper on effects of examples on problem-solving vary as a function of example presentation interface design. This is joint work with my co-authors Jason Ding, Eesh Kamrah, and Mark Fuge. We're all at the University of Maryland. Examples are ubiquitous in creative problem solving. They are partial solutions to the same or related problems. They can take on various forms, like prototypes, sketches, and images, etc. Importantly, examples can lead to inspiration, improving creative processes and outcomes, but also sometimes cause fixation, blocking new thoughts and making it harder to come up with creative ideas. Our work is situated in a robust body of HCI research on tools for example-centric creativity support. We have lots of work on tools for discovering examples, structuring or analyzing and exploring collections of examples, and adapting and using examples. In this paper, we are focused on the question of how we should make practical design decisions when building these example-centric creativity support tools, with a particular focus on theoretical guidance. Let me explain a bit more what I mean by that. Practical design decisions we have to make when we build these tools can include things like how many examples to show and where, separate from the main task, in a pop-up, how to display examples, in a list, in an accordion or carousel, in a gallery, and what information about examples should be shown or made accessible, like example quality, relatedness to other examples, and attributes. On the other side, we have a nice, robust body of work examining how people use examples in the creative process. And in this paper, we focus on a particular set of psychological mechanisms. We call them example use strategies, ways of processing examples in the creative process. There are two particular strategies that we're interested in here. One is using examples as a starting point to stimulate new ideas, although sometimes this can lead to fixation. And using examples to formulate a model of the problem space. So instead of using them as starting points, you use them as inputs to a formulation process where you try to understand the parameters of the design problem or understand, what are some good or bad approaches to take. And then from there you can use the model to generate new ideas. These strategies in turn can have different relationships to the problem-solving outcomes like novelty, quality, etc. In this paper, we want to focus on how the display of examples can relate to example use strategies and then in the end impact problem-solving outcomes. So our research question in this paper is how do practical design decisions about how to display examples shape their use and impact on problem solving? We studied this question with the Wildcat Wells task, which is an analog for exploratory creativity. This is inspired by the real-world task of wildcat drilling, where you build these wells and drill them outside of an area known to have oil and gas. This can be quite risky to the tune of millions of dollars because you don't really know whether there's going to be good oil or gas in that location. So in this way, this task is characterized by uneven and unknown distribution of solutions in the space, which is a core feature of exploratory creativity that we can use to model the use of examples in creative work. We put this into a interface where the task is to search for rich oil spots in a 100 by 100 grid. And the way you do this is you simply click on the grid to drill, and you'll get feedback on whether there's oil or gas in that location in the form of a score. Importantly, similar to its use in previous studies of problem solving, we systematically set the ruggedness of the search landscape. For instance, we include multiple peaks instead of a single peak to model the rugged nature of problem spaces that are characteristic of exploratory creativity. So you can't just use a hill climbing strategy to kind of get to the top. You have to use different strategies to figure out how to get to good spots. In this work, we tested 3 example presentation interfaces. The first one is a list, which is inspired by a common default presentation of recommendations and examples that you might see, say, on Netflix or search engines. And in our interface, it looks like this. We have a list of example moves with their scores that you can kind of scroll through. We also designed a drop-down interface that we hypothesized would be pretty ineffective as a way to interact with examples. Makes it hard to compare examples easily. You use it, you kind of click through to see individual examples one by one. And the third design that we tested was inspired by a novel class of example-centric interfaces in HCI that contextualize examples in the workspace or problem. Shown on the right here is the example image sense, where you have this mood board space and you can sort of place your own ideas as well as example suggestions from the system on the same space. So in our system, it looks like this. We simply overlay the example moves with their approximate score values on the grid itself. So you can see the example moves in context of the landscape. We then test these example presentation interfaces in a control experiment. We had 182 MTurk workers who had at least 99% approval rate with at least 500 hits completed. We paid them $10 per hour. We did a mixed design experiment where we varied across participants, randomly assigning them to view examples in a list, a drop-down or in-context interface, and then within subjects, we have them do one trial each with low versus high diversity example sets. We did test, we saw similar divergent thinking scores and exploration patterns across conditions before seeing examples. And the paper also has some more details on example diversity results. In this talk, we'll focus on the presentation interface effects. We also give them a 60-move budget for exploring. This adds some time pressure. We do complete the task in approximately 4 minutes per trial. We also give them incentives for performance. They get a 1 bonus for having a high score above some threshold, and then a 50-cent bonus if they hit the max score of 100. So onto the results. We have 3 main sets of results. They're interesting to discuss. We do see significant variations across the interface designs in terms of task performance, example use strategies, and exploration patterns. So first, task performance. This is measured in terms of the best score that they were able to achieve during a trial. So on the y-axis here, we have the best score averaged across participants in each condition. And on the x-axis, we have in-context list and drop-down conditions. And what we see is that the list presentation of examples is associated with the worst overall task performance, significantly worse than both the in-context and drop-down conditions. What's interesting also is that the magnitude of this effect is comparable to the advantages of seeing diverse examples as opposed to non-diverse examples. So to try to figure out what's going on across the different conditions, we looked at their example use strategies. We began with the self-reported example use strategies. We had a open-ended question at the end of the experiment where we asked participants to describe how they used the initial examples. Some example comments look like this. I didn't give it much thought. I started at the reddest one, which is like really high score, explore surroundings, get a vague idea about whether there may be hot or cool zones around those points. And then, informed by the literature on example use strategies, we classified each comment in terms of what strategy it seemed to be exemplifying. We achieved Cohen's-Kappa of 0.73, classifying comments into not using, stimulation-based, or model-based strategies. Then we examine how these frequencies vary across the interface conditions. So on the y-axis, we have the proportion of people in a given condition that are self-reporting using a particular strategy. And then again, we have our example conditions on the x-axis. So these are the overall results. Let's take a closer look at some key patterns in here. So the first pattern is that the in-context participants were quite a bit more likely than the other interface conditions to self-report using a model-based example strategy. These are exemplified by comments like, get an overview on which squares would be best, get a sense of whether there are hot or cool zones on the landscape. Second pattern, the list participants were also quite a bit more likely to self-report a stimulation-based versus model-based example use strategy. And then the drop-down participants were also more likely to self-report not using examples, particularly in contrast to the in-context participants. This was also corroborated by log data. Approximately 2/3 of them never clicked on the example dropdown to view another example. So this made us wonder, how does their self-reported example use strategies correlate with their actual exploration patterns? If you recall, the exploration patterns kind of look like this, right? They're sort of over time exploring the landscape, uncovering spots and getting score feedback. Some of them look like this, and some of them look like a bit more incremental in exploration. So intuitively, you can sort of notice some differences across exploration patterns. They look like they're exploring or modeling, and some look like they're kind of hill climbing. So to formalize this, we converted their exploration sequences to a sequential distance graph. So on the left here, you can see we have a graph where on the y-axis is the distance of a particular move from its previous move. So when it's high, it means that the move was far away from the previous move. And when it's low, it means it's pretty close by. And so on the right here, you can see an example exploration pattern that starts out sort of exploring across the landscape and then zeroing on a particular region and setting moves close by. We then divide the sequential distance graph into 10 move windows, and then we code each window as hill climbing or not, where hill climbing is a mostly flat graph where all the jumps, all the moves are pretty close to each other. We achieve a cohort kappa of 0.78 for this coding. And then we focus on classifying the first 30 moves as all hill climbing or not to kind of capture the overall sense of their initial exploration, which we hypothesize would be most tied to example use, since they saw the examples from the very beginning. So now we can examine how this varies across the three interface conditions. On the y-axis, we have the proportion of people who hill climbed across their first 30 moves. Here we see something that mirrors the example use strategy data as well as the performance data. The list participants in particular were much more likely to mostly do local initial exploration, i.e. all hill climbing the first 30 moves, compared to in-context participants. So in sum, our results kind of mainly focus on the in-context versus list contrast. In-context presentation examples seem to lead participants to use examples to formulate a model of the problem, and the list presentation seemed to encourage stimulation-based strategies for using examples, which in our study ended up fixating them, meaning they led to worse task performance. From a design perspective, this suggests that the default list presentation may actually be not a great option to start with. It may mute the benefits of examples. It's probably worth considering how to contextualize examples in a workspace problem if you're going to use examples in your tool. From a theoretical point of view, it's interesting to note how these seemingly quite banal practical interface design decisions can have quite psychologically significant implications for how people use examples and how it impacts their problem-solving performance. So we're particularly interested in sort of using this to build out a theory of human example interactions, thinking through the mappings between practical design decisions, psychological mechanisms, and problem-solving outcomes. So in our study, we can kind of model it out as displaying examples. You can choose between doing it in a list or contextualizing in a problem space that kind of connects to example use strategies like stimulation and formulation, and then that in turn can have negative or positive consequences for the Wildcat Wells task specifically. What we would like to do is to expand this out to explore other strategies or interaction design questions, other psychological mechanisms like conceptual combination or analogy, and examine this in much more complex settings or different problem-solving tasks like design and research and other process outcome metrics.